Okay, here is Unit 4, 9.1. So we're going to go through a whole page of definitions, okay? We're going to get them on and then we're going to talk about them as we go. So, a monomial. A monomial is a number, a variable, or the product of a number and one or more variables with whole number exponents. Okay? So a monomial, it's just a term. Um, 2, x is a monomial. X is a monomial, just x. 3 is a monomial. So some examples. All right? Um, the degree of a monomial. So the degree of a monomial is the sum of the exponents of the variables in the monomial. So, for example, x would have a, how many exponent, what's the exponent? 1 would be a first degree. X squared would be a second degree monomial. Okay, maybe a tricky one, what would 2 be? Well, let's look. It's the degree is the sum of the exponents of the variables. Does it have any variables? No. So it really has a, maybe an x to the 0 we could put it there. So a 0. So that degree would be 0 for just 2. Okay? We're going to get some more practice with that, but that's what the degree means. So, monomial. 20 is a monomial. What's the degree? Well, we kind of talked about it. It's 0. Are there any variables? No. So if there's no variables, it's 0 degree. 15x, what's the degree? Well, sum of the variables, x has a 1, so it's a first degree. 2/3, g, h to the third. Remember, it's the sum of the exponents of the variables. So g has a little 1, h has a 3, so this is a fourth degree. So fourth, the first degree. What about negative 4.9 k to the eighth? Well, it's just an eighth degree monomial. Okay, so we add up the exponents. Doesn't have an exponent, just a number. It's a 0 degree. Let's talk about what is not a monomial. So, not a monomial. X plus 25 is not a monomial. Why is it? A sum is not a monomial. Okay? If we're adding two terms together, that's not a monomial. 3 over y. This is not a monomial. Why? Because a monomial cannot have a variable in denominator. Okay, since the variable's in the denominator, it's not a monomial. Okay? 4 to the w power. It's not a monomial because it cannot have variable exponent. Variable exponent. I'll write that. Exponent. Okay? X to the negative 4, not a monomial. Variable must have a whole number exponent. Negative 4 is not a whole number. Whole numbers, remember, are 0, 1, 2, 3. And if we rewrite this, we would really be 1 over x to the fourth, which, since the x is in the variable, it can't be a monomial. So these ones can't be monomials. Let's do a couple other definitions here. A polynomial. Polynomial is a monomial or a sum of monomials, each called a term of the polynomial. So polynomial just means many. So it's more than one. Okay, it's a monomial or it's the sum of monomials. So polynomials are the big umbrella. They cover everything. Degree of a polynomial. It's the greatest degree of its terms. Okay? So we don't add them up, it's just the biggest degree. Okay? So if I had like 2x plus y squared, well, that would be a second degree polynomial, because 2. We don't add them up, we just say the biggest one, the greatest degree of its terms. Leading coefficient, the coefficient, so leading's like the first, the coefficient of the first term when a polynomial is written so that the exponents of a variable decrease from left to right. Okay? So we'll do some examples, but that's what the leading coefficient is. A binomial is a polynomial with, what's a bicycle? A bicycle has 2 wheels. This binomial has 2 terms. So this was a binomial up here. A trinomial, a tricycle has 3 wheels, so it is a 3-term polynomial. So it's a polynomial with 3 terms. Okay, a lot of definitions there. Okay, so now we're going to figure out what some of these, how do we figure out what the degree is, how to write in descending order. So this chart, we're going to have an expression here. Is it a polynomial? If yes, we continue. So is 12 a polynomial? Yes, it's a polynomial. What's the definition of polynomial? It's a number or variable. So write in descending order. So you remember descending order, we're going to write it from highest degree to lowest degree. It descends. So there's only one term, so that one's kind of simple. It's just 12. What's the leading coefficient? Once again, it's just 12. Classified by degree and number of terms. So what's the degree of 12? Remember, you count up the exponent of the variables. No variables, so it's a 0 degree, and we want to classify by terms. Monomial. 0 degree monomial. Okay? So that's how this chart works. Let's do 3x squared plus 2x minus 10. Okay? So we want to find, is this a polynomial? Yes, it's a polynomial. Doesn't have any variables in the denominator, has whole number exponents. So we want to rewrite in descending order, meaning this is degree. We look at these x's. Here's 2 x's, here's a single x, there's 0 x's. We want it to going down like that. So it's 3x squared plus 2x minus 10. Now, the leading coefficient, if we write it in descending order, it's the number in front of the first variable, the variable with the highest degree. Leading coefficient is just 3. Classified by degree and number of terms. So what degree is this? It's a second degree. Remember, we don't add up the terms, we just take the highest one. So it's a second degree, and it's got 3 terms, so we can classify it as a trinomial. Okay? What about this one? 17n cubed minus n plus 6 to the n power. Is it a polynomial? Well, since it has a variable in the exponent, no. And we're done with this. We don't, it just says if yes, we continue this row. Let's look at this expression. Negative 2x y cubed plus 3x squared plus 3x squared y to the fourth. So I'm going to write the degree over each term. So what's the degree of this first term right there? Or is it a polynomial, first of all? Yes, it is a polynomial. So yes. And what's the degree of each term? So this has 1 over with the x for the exponent and a 3. So this is a 4th degree term. This is a 6th degree term. So when we write in descending order, we want the higher number first. So this term is going to go first. 3x squared y to the 4th minus, I'm just going to rewrite this term now, 2x y to the 3rd. Why did I switch it around? Because this term is a higher degree. You want descending order going from highest to lowest. This is a 6th degree going down to 4th degree. So I rewrote it. Why is that important? Because when I rewrite it, the leading coefficient is the number in front of the highest degree term. So leading coefficient is 3. You want to classify by term, by number of terms and degree. So what degree is this? You just look at the highest degree, remember. It's a 6th degree binomial. Only has 2 terms. Okay? You guys stop the video, try these. Remember, you have to write them in descending order. You might have to rewrite this one. Okay? Try that. Figure out where you're at on our for our learning targets. Okay, hopefully we tried these. If not, come in with some questions tomorrow. Adding polynomials. So we add like terms. You may add vertically or horizontally. I'm going to do both here. So I'm going to try horizontally first. So this is horizontally. You can do either one. We add like terms. Like terms mean they have to have the same variable but the same exponent. Like terms. Maybe we should write that. Same variable, same exponent. Okay, so I got 5a squared and 8a squared. So what does that equal? 5 plus 8, I have 13a squares. Okay, we don't add the exponents. That was multiplying, that was last unit. We're just adding these things. I have 5 of these things. You have 8 of these things. Total, we have 13 of these things. Okay? And then I'm going to write 2 little lines underneath the numbers so I can keep track. Negative 3 plus a negative 1 is just going to be negative 4. That would be my answer. I added these polynomials. We just add like terms. Okay? I'm going to show you how to do it vertically now. I like doing it vertically when there's more terms. I think it makes more sense sometimes. So, if I was doing this horizontally, I'd look, h squared, I got more h squareds here. I could add them up and keep going. I'm going to rewrite this. I'm going to rewrite this right underneath. So I'm going to say 5h squared. I'm going to put this h squared right underneath here. These h's are going to go underneath these h's. Minus 8h. The 2 is going to go underneath the constants. So now I got my h squareds here, h's, and numbers. I'm going to add h squared plus 5h squared gives me 6h squared. 4h minus 8h gives me a negative 4h. Negative 4 plus 2 gives me a minus 2. That's going to be my answer. Could you have done it vertically? Yes. H squared plus 5h squared, 6h squared, 4h plus negative 8h is negative 4. This one sometimes is organized a little better, and it's going to help us out when we subtract. So, you guys try these U-tries, and then on the next page, come back and shade where you're at. Okay, we did adding, now we're going to do some subtracting. So, how do we subtract polynomials? Well, we add its opposite. If I give you an example, if I said, what is 5 minus 3? I think everybody would say 2. But I could also say 5 plus a negative 3 equals 2. Okay, so we can add its opposite. That's what we're going to do here. Multiply each term by negative 1, then add. So when we subtract, what this is talking about is, how did I do that? Well, I multiplied this term by negative 1, and then I added it. So I took the 3, multiplied it by negative 1, I get negative 3, and then I turn this to an adding sign. So what does that mean? I'm going to take 3c minus 5, and I'm going to multiply it by negative 1. So I'm going to distribute. And I get a negative 3c plus 5. I'm going to take that, and I'm going to add it over here. So I'm going to rewrite this. 6c squared plus 3c plus 9. I'm going to add this to it. I'm going to do it vertically. If you want to do it horizontally, that's fine. So under the c's, I'm going to put the c's. Negative 3c goes underneath the positive 3c. 5 goes underneath the 9. I'm going to add. 6c squared plus nothing is just going to give me 6c squared. 3c minus 3c is 0. I'm not going to write it there. 9 plus 5 is 14. Whoops, 14. And that's going to be my answer. Okay, could we have did this 6c squared minus, there's no c squared. I could say 3c minus 3c, I get 0. 9 minus a negative 5, well, I got to add that. That's why we want to change it to addition. Makes it much simpler, less errors. Okay? So I just did this little first step, I did off to the side. So we can do it over here too. I'm going to do this off to the side. So I'm going to distribute this negative 1. I'll write it over here. Negative 1 times 4x cubed plus x squared minus 15x plus 1. I'm going to distribute this negative to each term. What do I get? Negative 4x cubed minus x squared plus 15x minus 1. Basically, is all I do is change all these signs. Look, positive 4x cubed, negative. Positive x squared, negative x squared. Negative 15x, positive 15x. Positive 1, negative 1. So I just change all the signs. Now I turn it into addition. So here's another trick with vertical. If we're adding vertically, I'm going to say 3x squared and I'm going to add this. Since there's no x, I'm going to say it's plus 0x. I'm going to hold that place, minus 8. I want to have all the powers of x represented, because when I do it vertically, I can line them up then. So, x cubes, do I have any? No, they're going to go over here. So this is going to be plus a negative 4x cubed. X squareds, I got a minus x squared, so minus x squared right underneath the x squared. X's, positive 15x. This is why I held that place with the 0x, because now I have a place to put it. And a minus 1. So I'm going to turn this into addition. I already did that by multiplying by negative 1. Now I get negative 4x cubed. 3x squared minus x squared gives me a positive 2x squared. 0x plus 15x gives me a positive 15x. Negative 8 minus 1 is negative 9. That's my final answer when I subtract. Could you have done it horizontally? Yes. Just have to make sure you keep all your x cubes together, your x squareds together, your x's, and your numbers. Okay? You guys try the next two, shade the bar at the bottom, figure out where you're at. We got one more problem. Okay,